Hi, Victor Morganti here from FactEngine. We're going to have a look at some new technology that FactEngine is offering customers from the 1st of July 23, which is openCypher over any relational database. I've put a little disclaimer, which at this stage we're just looking at read-only and no metagraph queries, but run-of-the-mill openCypher queries synonymous with simplistic SQL queries. We will be moving to metagraph queries as if you were looking at a graph database when you look at any relational database. And of course we'll be implementing the ability to create records using openCypher as well. We feel that this technology is going to be exciting to customers for a number of reasons, and if I give you a demonstration, I believe you'll see why FactEngine is particularly excited about this technology and how it fits into the FactEngine lineup of products, and where we believe that the technology is going to offer significant benefit to customers with a need for Cypher or graph queries over any relational database. We're not talking about relational databases that have been fudged in some way with special tables or special makeup of tables. We're talking about any single relational database that's extant, and where FactEngine has set up for that database. I'll give you a demonstration over one database today and paint a picture of where we're going, but customers can approach FactEngine now to set this up over their database, and we believe that we can do this over practically any relational database. In fact, I can make that guarantee. So let's have a look at it. Inside the Boston conceptual modeling software, we're looking at a relational database called Cinema Bookings, and I'll just show you that we're inside Boston. So this is the Boston conceptual modeling software by FactEngine. This demonstration will start off inside Boston, but then we'll show you the generalized API that we can offer customers to provide graph queries over your relational database. So inside Boston, we're looking at a relational database. Now you might look at this and say, well, that's a property graph schema, but we know that in Boston every database is treated as if it's a relational knowledge graph or a graph relational database, and where FactEngine is a thought leader in the relational knowledge graph space. So we're looking at a relational database or a traditional relational database, and if we notice where many-to-many tables have a primary key, and the hash here denotes the primary key across multiple columns, we get a feel for where we're not setting up a special type of table to affect an edge. So this edge here, booking, has seat, where we're taking a run-of-the-mill relational database and we're treating it as if it's a property graph schema, and I'll be showing you openCypher queries which don't require specialized edge tables to affect the edges in the property graph view. And why that's important is because the technology will let you operate over any relational database that's in production in your data warehouse or your production database environment as it stands today. So this particular database is a Neo4j database, sorry, a SQLite database, and you can see the SQLite logo there. If I go to the model configuration, we can see the .db file that's being pointed to there, and we're set up for SQLite, so I can test that connection, which just says that that file exists basically, and we can apply and OK that. Now we know that inside Boston incorporates FactEngine, which is the namesake of FactEngine's business. And if we open FactEngine, we know that we can write controlled natural language queries, which are graph queries, against a otherwise relational database. So I'll do that. So I'll say which on, in fact I'm going to say person Peter made a booking to watch which film at which cinema. Now before I hit go on that, I'm going to tell you a bit about this database. So some attribution. The original schema for this database was created by Data Constellation and shared on GitHub. And the schema is for cinema bookings, where a person can make bookings for a session to watch a film at a cinema, and the booking is for a seat in a row in a cinema, and a seat can be in a section such as the gala or the deluxe section or something like that. Now I've got a picture which will demonstrate that. So this lady is on the phone and she's booking a ticket for her cinema. In her mind's eye, she's already sitting at the cinema. She's got her seat, she's got her popcorn, and she's made a booking which goes in our database, where that person made a booking for a session to watch a film at a cinema, and she's booked a seat in a row in that cinema, and the seat is in a particular section in the cinema. So we've asked the question, person Peter made a booking to watch which film at which cinema. Now let's hit go on that, and we can see that Peter has made 3 bookings, and he's made bookings to watch Rocky, Grease and Dr. Zhivago at the Great Western Cinema on these dates. We know also that in FactEngine we can open a natural language, a complete natural language or free-form natural language text box, and we can write our same query in free-flowing natural language. So I'll say, show me the cinemas and films that Peter made a booking for. Now I don't know if that's going to work. We'll give it a go. So that's going to be shipped out to a large language model, and it's going to be converted to FactEngine query language. And excuse me. Let's come back and asked us to just temporarily get rid of our has label on this relationship between booking and seat. Let's go back here and run that query again, and there's our results. So we've written a natural language query, show me the cinemas and films that Peter made a booking for, and that's been converted to a controlled natural language query. Person Peter made a booking for which seat, for which session, to watch which film at which cinema, and that's given us the same results as our previous controlled natural language query. I'll just go and put the the has label back on here. So that we can see our property graph. Now, the direction that the database industry is moving towards, and where FactEngine has made a preemptive move, is to have the ability to write openCypher queries, so graph queries, directly against the relational database, just because we can, and because there's a benefit to customers there, where in an emergency, for instance, where a customer wants to change databases either away from a graph database or to a graph database, the ability to able to switch their queries from, say, SQL to Cypher or openCypher is of a huge benefit to especially a large customer with quite a large database, to be able to minimize the risk of the database transformation project. Now, this query here, or these queries, have been converted to SQL because we know we're looking at a relational database. Now, this could be Oracle or SQL Server or Postgres or any number of the hundreds of relational databases available. So even looking at technologies such as Presto, or even Snowflake, or even Hadoop or something like that. So we've got an SQL that we're running against a database or a semantic layer of some description. So if I erase that query and change our query type to Cypher, and find a Cypher query, which I'll just copy and paste in there. This is pretty much the exact same query, but in Cypher, openCypher. Now, there's a benefit to customers there too, where FactEngine provides what we call the semantic view, where the world is moving to having more semantic type knowledge available for a database, such that it's easier to understand the schema of a database and what it's storing and what the story it effectively tells. So those who read graph queries arguably could get a better feel for the schema of the database, because there's natural language in the predicates. So booking is for person, booking has seat, seat is in row, row is in cinema, etc., rather than just looking at a entity relationship diagram, which does have predicates in this stylized Barker-EI ER diagram. There will be those who prefer to write queries in a graph query language. Now, if I run that, I should get the same information back. So Peter booked Rocky Grease and Dr. Zhivago on those 3 dates at the Great Western Cinema. So we've gone from openCypher to, and I can show you just briefly how that's been converted to SQL. And here's our converted SQL to bring back our results. Now, this technology here is courtesy of Microsoft. So if there's any credibility behind the technology, I can just show you just briefly what FactEngine has done is taken Microsoft's openCypher transpiler, which was restricted to tables that must already be normalized to be used as graph node edges, which is shorthand for saying single column primary keys. And FactEngine has taken that technology and modified it under the MIT license for that open source software, where it can transpile cipher queries over databases that have relational databases that have entities with multi-column primary keys. So under the MIT license, we're not obliged to share the code that we wrote to make that happen, and that becomes the secret sauce of FactEngine, where the product offering is the ability to employ this technology on site to connect to a whole range of different relational databases without modifying the structure of the relational database at all. And I'll show you something quite interesting and extraordinary in a second, where we prove that point and give an inkling of how, in a risk-free manner, you can employ this technology across your existing relational databases with the minimal of effort and practically zero risk to your existing production environment, such that you get openCypher queries against your relational database. So let's just recap for a sec. We've got a SQLite database that is a relational database that, through FactEngine's technology, we can view as a property graph schema, and where through FactEngine we can write controlled natural language graph queries, or natural language queries, which are graph queries by default, which get translated to the language of your database. Now, this need not be a relational database for FactEngine. This could be a Neo4j database, and these queries would be converted to Cypher. But we have offered the ability now to write Cypher itself against, openCypher against a relational database, where those openCypher queries are converted to SQL. And this could be Oracle, SQL Server, Snowflake, Postgres. This could be an at-scale or MariaDB, a whole range of relational or entity relationship diagram style databases, and that employ SQL, and this openCypher will run against that. Now, as the project progresses, we'll extend this to have metagraph type queries, say shortest path, for instance, etc., and where it'll be up to our customers, you, to decide whether or not you're getting the performance you need. There can be a whole range of reasons why you need to write openCypher queries, and where having a graph native database need not necessarily be the most defining thing for you, where such databases as SQL Server, for instance, from Microsoft, openly claim to be the fastest database in the world anyway, whether graph or relational. So we'll leave that to you, because FactEngine is about, or is in the business of, offering choice, and the largest possible offering of choice available to our customer is what makes us happy, because you get to keep the investment you've made in your existing databases, and we write the technology to sit over the top of your existing data infrastructure. So I'll just pause for a second and capture my thoughts, and we'll dive back into this. Now you might be asking yourself or saying to yourself, well, look, this is all well and good. You're inside Boston and you've got FactEngine inside Boston and you can write these queries inside Boston, but how does that help me in a production environment with my data warehouse? So let's touch on that for a second. So Boston is available as a desktop application, but also as Boston Enterprise through a web browser with user access controls where you can serve Boston and FactEngine as a business intelligence engine and semantic view engine, and where we can see a broader semantic view in natural language of business rules using object role modeling as the back end of Boston. And over the web through a browser you get the same functionality to do your business intelligence and to have a semantic view where analysts or knowledge engineers can look at the schema in various views or as natural business language, but also write natural language queries and control natural language queries through their browser over your data warehouse. But also Boston Enterprise, it can be set up on an intranet or an extranet. So the offering range is quite deep there, that once again you get choice as to whether or not you're using FactEngine from a desktop or people are doing business intelligence and knowledge engineering in a collaborative fashion over the internet or through an intranet or extranet through a browser. And FactEngine itself is available as a RESTful API where your software can hook directly to FactEngine. The engine for openCypher queries we're going to offer as a separate product also. So it will be inside FactEngine, which is available from the desktop or via a web browser or a RESTful API over the internet or a intranet or extranet. But also we can provide the libraries for you to create your own API for openCypher queries against your database or your data warehouse. And I'll give you a quick demonstration of that, and you can just see how easy this software is, and then we'll talk about why it's zero risk for your business. So let's do that this way. So I've got a blank notepad page there, just so that I've got a white background. I've got a very simple application that I've written in .NET that has a button and two text boxes, and I'll grab my Cypher query again, so I'll just copy that and paste it into this text box here, and I'm going to run the query, and I've got my same results. So Peter booked Rocky, Grease and Dr. Zhivago at the Great Western Cinema on these dates. Now this is completely outside of FactEngine and is in technology we're calling MindfulDB or Mindful. Now MindfulDB is the accumulation of libraries to simply create your own API or integrate into your own application, the ability to write openCypher queries to the extent that you can at this stage without metagraph queries over your relational database. And we're talking any relational database, and I'll show you how we achieve that in 1 second. There's two ways to do it. I'll show you both ways. Now, if I close that application and show you the actual code behind it, you'll see that it's very simple. So this is the extent of all of the code in the application. So about 30 lines of code. This is in visualbasic.net. We've got a method that handles the load event when the Windows Forms app opens, and when we click on the button, this code here is executed when we execute the query. And to be honest, this bit of code down here is just to display the results. So it's as simple as saying our query is a string, get it from the text box, check that it's not an empty string, and then run the query. We dump it into a specialized record set, but we can put that against any type of data layer that you want or prefer. So let's run that, and I'll show you what's happening. So we're about to run the Windows Form app. We are setting up a new instance of MindfulDB, which is the API for openCypher queries against any relational database. In this line here, we're saying that our database type is SQLite. We're setting a database connection string that I've got in my settings, and it's just a path to the cinemabookings.db on my OneDrive folder. And so that's our connection string. We're going to connect to the database. Now this line here is where all the magic happens. We're going to retrieve the relational data structure, which effectively pulls the meta model of the database into memory so that it's available for our transpiler. At the same time, it's creating a property graph schema view, or a graph view, of our relational database using the secret source that FactEngine and Boston provide. You don't need Boston to do it, but Boston certainly makes life a lot easier to set this up. Now notice that, and I'll show you, if I go to a SQLite Studio view of the database, here's our tables: booking has seat, cinema, film, person likes film, row, seat, section, and session. We haven't made any changes to the tables at all in the schema. We haven't introduced any special edge tables. We haven't created any special node tables. These are just vanilla relational database tables. And in SQLite we can run this query here, select SQL from SQLite master, where name equals seat, for instance, and we can't really see everything there. I'll just make that a broad-based query. We can see all the database definition language for the various databases, tables in the database. If I double click, say, on booking has seat, that's quite a busy table. Here's all our columns that correspond to our entity relationship view for booking as seat over here. So we haven't made any special changes to the database at all, and I'll show you the secret for how MindfulDB works in a second. So just give me 1 second, we'll come back. Okay, let's go back to our application. So we're simply pulling the meta schema from our database into memory, so both the relational view and the property graph schema view, and you'll see the form open up. Now again, if I grab my query, so my openCypher query, and put that into the text box and now hit run the query, we're getting a variable ls query from the text box text. We're checking to see that it's not empty, and we're running the query. Notice that I've got the type of query as written as cipher here, and here's our query here. So that's the openCypher query that we're running. We're going to run that, get it inside a record set, and the rest of the code simply displays the results in this text box down here. So it's very simple, and that is a product that we have available to our customers now. So if you get in touch with FactEngine, we'll help you get that set up against pretty much any database you like. Now give me 1 second, I'll be back and I'll show you how it works. So you might be asking yourself, how the hell did I just run a openCypher query against a relational database that to all intents and purposes is a stock standard relational database? So I'll show you the secret sauce, and the reason why I'll reveal that is because if you're a lead architect with an organization managing a multi-million-dollar data warehouse, you want to understand why it's risk-free for you to introduce this technology to your data stack, now your business intelligence stack. So let's have a look one more time at a couple of different things. So you're going to get a glimpse of some of the databases in my test folder. I use SQLite quite a bit because it's just handy. So here's the actual file for our database, cinemabookings.db. It's just a single file. We've got a standard run-of-the-mill database file that we've just used in our application, and we've made no changes to this file which are controversial in any way whatsoever, and I'll show you how we've done that. Now if I go back to Boston and look at our relational database, we know that this booking has seat table is a many-to-many table, which is a edge in our property graph schema view with a label of has. Now if I click on the edge type, I can see its database name is has. If I go back to my entity relationship diagram view and click on that table, I can see that its database name is has. We're looking at exactly the same thing. Now that's an edge type by default, and really we've had to make no changes to our database at all other than have an edge label or an edge type label against our table. The same is true for foreign key relationships, which are edge types in themselves. So if we say a seat is in a row in a cinema, and where our edge label is in, this edge type here is this foreign key relationship between seat and row, and if I click on that, I can see that that foreign key relationship has a DB name or an edge type label is in. So really we haven't had to do anything special to our database at all to make it into a property graph schema. Now that might be surprising to some people, and those who know this space very well will know that, for instance, Microsoft and Oracle have gone out of their way to make special edge tables and special node tables. What FactEngine and MindfulDB are saying is that that isn't necessary. We can take your vanilla relational database and convert it into a graph database with very, very minimal, in fact no alterations to the database at all. So let's have a look at how we do that. If I go back to SQLite Studio, which is a database manager for SQLite, and I run a query against the SQLite master table, we get to look at the database definition of the various tables and model elements within our database. So I'll run that, and if I look at, say, the seat table in SQLite, we store in the SQLite master database the complete database definition for that table. So I'm going to show that in a viewer, and here's our create table statement. Now notice that our foreign key reference to section and foreign key reference to row have a comment against each of those foreign key references, which the comment contains a piece of JSON, and the JSON has our label is in. So seat is in row and seat is in section. Now if we go back to our schema, we can see that seat is in section and seat is in row. In our property graph schema, seat is in row and seat is in section. And what we've done is we've simply added comments to our database definition language stored in the database that say what's going on at the property graph schema level for our database. So the risk of implementing this technology is nil. We're effectively documenting our database. Now FactEngine has checked, and this same capacity is available within Oracle, it's available within SQL Server, it's available within Postgres, it's available within Snowflake, it's available in just about any database. And if the ability to add comments isn't available at the database definition language level, we'll just simply provide a file that gives you the property graph schema annotation to your tables to effectively execute the same technology. The easiest way though is to simply store a comment with JSON in it with the edge label type directly in your database. Now Oracle and SQL Server don't store the whole create table statement the same as SQLite, but nonetheless you can add comments against foreign key references, for example. Now let's have a look at booking has seat. Now booking has seat is a many-to-many table. If I view its create table statement, it has a primary key which is defined across a range of columns there, and we have a has label, so a comment with the label has against that primary key. Now let's have a look at that inside our schema. So booking has seat. This edge type is a many-to-many table with a primary key against 1, 2, 3, 4, 5, 6, 7 columns. That primary key in SQLite is stored in the create table statement, and we have simply put the annotation as to the property graph schema edge label against the database definition language stored within the database. So we can do this for Snowflake, we can do this for SQLite, we can do this for Oracle, we can do this for Postgres, we can do this for just about any serious relational database. And if your relational database doesn't allow you to have comments, we'll just simply provide an annotation file that you can store that will be accessible via your API to be able to quickly get the property graph schema view for your database. Now the secret sauce, of course, with MindfulDB and FactEngine, or the FactEngine offering, is that we have taken Microsoft's open source software and modified it such that it runs over any stock standard relational database schema. So let me wrap that up now. So FactEngine is now offering technology that will give you openCypher queries over any relational database, and with the caveat that that's read-only at this stage, no metagraph queries at this stage, and we need to configure it for your database. It only takes a day or so to configure it for any new database. Please get in touch and we'll do it. The technology is transferable across any relational database. The risk to you as a CEO or a lead architect or a developer or a knowledge engineer is zero. There's no risk. And the reason why is that we're effectively documenting your database schema. We're storing the property graph schema information, which really wasn't all that hard, directly against the schema in the meta model of your relational database. So if you're working with a semantic layer, FactEngine is in the business of providing what we call a semantic view over the top of your semantic layer or your various databases, where with our semantic view we have FactEngine, which allows controlled natural language queries or natural language queries that can be converted to SQL or even Cypher, and where that's available as a RESTful API in the cloud or in intranet or extranet, and available through Boston through a web browser. Boston is available on your desktop and allows you to write the SQL or openCypher against your databases. And FactEngine is now offering something new within the mix, which FactEngine is calling MindfulDB or just Mindful. Now, we call it Mindful because those who really know and understand databases realise that the database industry is moving towards an era where everyone is very mindful that a relational database can be viewed as a graph database and vice versa, and where the logo for Mindful tries to capture that, or captures that, by showing the merger between black and white, and the melding together of the two paradigms. So the openCypher against any relational database technology is available to you for just about any relational database. And if I pick on a few here, Snowflake, you'd be able to use the technology with AtScale, which is not really a database, but a semantic layer over the top of your databases. With Oracle or SQL Server, MySQL, any database that uses ODBC, we can be writing openCypher queries against those databases with the ODBC database. Probably not TypeDB, but certainly all the rest of these, even Neo4j as a JDBC interface, but you're writing Cypher against Neo4j anyway. So let's work backwards. So you have a relational database. You've got a need to write openCypher queries or graph queries against your relational database. You want a technology that's available now out of the box. MindfulDB is that technology. It's incorporated into Boston and Boston Enterprise in the cloud. FactEngine uses the same technology and with the added advantage of controlled natural language queries and natural language queries. FactEngine is in the business of providing a semantic view over your semantic layer or your existing databases or data warehouse, and where graph queries certainly lend towards a semantic view with the natural language predicates in the queries themselves. So you get to keep your semantic layer and the sunk investment you've got in your database. The risk to you is nil. We are effectively documenting your database and turning your relational database into a graph database by merely adding edge labels against foreign key relationships and many-to-many tables. And that's openCypher against any relational database. Thank you very much for watching. I look forward to speaking with you soon.
Thank you for watching. I hope you enjoyed the video. I'm Victor Morgani from FactEngine. FactEngine provides consulting on knowledge graphs, object role modeling, property graph schemas and relational models. And of course, FactEngine is the author of the world-leading Boston conceptual modeling software. Thanks again. I look forward to speaking with you soon.